Hello everyone. So this is a question from NEET 2025. The correct order of decreasing acidity of the following aliphatic acids is, okay, aliphatic, HCOOH, CH3COOH, CH3 twice CHCOOH, CH3 thrice CCOOH. The chapters involved is aldehydes, ketones and carboxylic acids, okay. So a little bit of prerequisite before we do the question. Let's talk about, carboxylic acid. So they are by far the most acidic amongst all the organic compound that we have studied, okay. So the next thing that we need to know is the effect of substituents on acid strength of these acids, okay. Effect of substituents on acid strength of aliphatic acids. Aliphatic means they don't contain any aromatic ring, okay, because in the question they have mentioned they are talking about aliphatic acids and they have given us 4. So we need to know that electron withdrawing groups, that is EWG, they increase the stability of the carboxylate ion, okay. They increase stability of carboxylate anion, or you can say ion, which is RCOO minus, okay. And this ion is formed when carboxylic acids show acidic character, okay. For example, RCOOH, when it loses its H plus, it forms RCOO minus plus H plus. So we can see that when the acid is showing its acidic behavior, these groups, they increase the stability of the product that it has formed, right. So these electron withdrawing groups, they increase the stability of carboxylate anion by dispersing or spreading the negative charge, and therefore they increase the acidity, okay. So how do they do this? By dispersing or spreading, okay. We'll see the diagram in a while. The negative charge, and therefore increase acidity. So to understand, we'll draw the diagram of the resonance hybrid of carboxylate ion, which is RCO and O. This is the resonance hybrid, okay. So you can see here electron withdrawing groups. So instead of, let's say R, let's write down electron withdrawing group. So what will this guy do? Obviously this will take away electrons. Can you see there is already negative charge in this system? So electron withdrawing groups, pull these negative charge and decreases the negative charge a bit in the system, and hence it stabilizes the carboxylate ion by spreading this, by taking out some of the negative charge, okay. But meanwhile, if we have electron donating groups, so what are these guys going to do? They decrease the stability of carboxylate ion, decrease stability of RCOO minus ion. They decrease the stability of these ions by intensifying the negative charge, and therefore, so they do so by intensifying or intensifying the negative charge, and therefore decreases the acidity of carboxylic acids, okay. With respect to diagram, it can be shown in this way. So for example, again we will draw the resonance hybrid of carboxylate ion. So we have CO and O, and this is the resonance hybrid, negative charge, electron donating group. Can you see there is already negative charge in the system, and electron donating groups, they donate even more electrons, and hence intensifying the negative charge, and hence decreasing the stability of the product that carboxylic acids form when they were showing acidic character. So therefore overall acidity decreases, okay. Now we have, in context, if you look at the acids that they have given us, they all contain alkyl groups, and alkyl groups have electron donating inductive effect. Always remember that, okay. Alkyl groups have electron donating plus I effect. Okay, so this will obviously increase the electron density in the OH bond, right? So if you, so there is one more way to understand. For example, if you have R C double bond O, so OH. So let us say we have a alkyl group here. So this guy is going to donate electrons, and you know it will be passed on to oxygen itself. Now oxygen, because it has got electrons from the alkyl groups, it won't feel the necessity to pull these electrons towards itself, and hence it won't feel the need to, you know, take these electrons to itself and then push on H plus out. So therefore this is one more way to explain. Or we can understand in this fashion that if we have, you know, a alkyl group which is an electron donating group, it will, you know, decrease the stability of the resonance hybrid of the carboxylate ion. This is one more way to understand. So electron donating groups, or you know, alkyl groups, they will increase the electron density, as we have discussed earlier. And plus I effect of alkyl groups. So the next thing that we need to understand is that plus I effect of alkyl groups increase in the order. So the order is CH3, then CH3 CH2, then CH3 twice CH, and then CH3 thrice C. So you can see it's very easy to understand, because more such groups, more is the plus I effect. Okay, so therefore out of the given 4 aliphatic acids in the question, obviously HCOOH will have the maximum, because it does not have any such plus I groups. Okay, then we will have CH3 C double bond O OH, because there is one such group which is donating electrons and hence making it less stable than HCOOH. Then we will have CH3 C CH3 C double bond O OH. Yeah, so because there are 2 alkyl groups which are donating electrons, and the last or the least acidic will be this guy, CH3 C CH3 CH3 C double bond O OH. So there are 3 such groups. You can see 1 2 3. Hence therefore this will be the least acidic, because 3 such groups are, you know, donating electrons to the system. Here 2 such groups are donating, that's why this is more acidic than the 4th guy. Okay, therefore this is 1st, 2nd, 3rd and 4th. This is the order. Okay,